Hey everyone, Mr. Lansing here, and our topic today is still on solving quadratic functions. To give you a recap, last week we started on solving zeros or solutions of quadratic functions, and we talked about two different methods. The first one was on graphing, where we use our graphing calculator or our Desmos calculator to find the x-intercepts, because those are the solutions of the quadratic functions. We also talked about factoring and the four cases involved in factoring. And today we're going to teach you the third method, and we're going to use this, what we call as quadratic formula, in solving for the zeros of quadratic functions. Our main focus for today is on solving quadratic functions using the quadratic formula. But later on, we will also be sidetracked because we are going to talk a very important concept involved in quadratic formula, and that is on imaginary numbers, or I. The quadratic formula is quite simple. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you're going to get the values from the given quadratic function ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x, and c is the constant value. Write this formula completely and clearly in your notebook, and make sure that you understand where to find the values of a, b, and c given a quadratic function. Aside from memorizing the quadratic formula, I'd like you also to understand what is the word discriminant. The discriminant is the value of b squared minus 4ac, or the value of the terms inside the square root sign. So as a discriminant, this value will tell you important things about your quadratic function's solution. So if the value inside is equal to 0, then you have exactly one real solution. If the value of the discriminant, or b squared minus 4ac, is greater than 0 or positive, it means that you have two real solutions. And if b squared minus 4ac, or the discriminant, is less than 0 or negative, then you have two imaginary solutions. So take note that this is the one that I talked earlier, that we are going to be sidetracked because we are going to talk about imaginary numbers when we are going to have an example that has any imaginary numbers as solutions. Let us go over our first example in finding the zeros of quadratic functions using the quadratic formula. In this example, the value of a is equal to 1, b is equal to negative 5, while c is equal to negative 24. And our formula is x equals the negative of b plus or minus the square root of b squared minus 4ac all over 2 times a. Now we're going to substitute the values of a, b, and c into our formula. So we have negative of b, and b is negative 5, so negative of negative 5, plus or minus the square root of b squared, and b is negative 5, so negative 5 as a quantity squared, minus 4 times a is 1, and times c is negative 24. Let's extend this one here, all over 2 times 1. That's 2 times 1 for a. Okay, so the negative of negative 5 is positive 5, and it's plus or minus the square root of negative 5 squared as the quantity is negative 5 times negative 5, that will be positive 25, and negative 4 times 1 is negative 4, and negative 4 times negative 24. Okay, negative 4 times 1 is negative 4, times negative 24 is positive 96, so this is plus 96, all over 2 times 1 is 2. Okay, so let us now simplify. We have 5 plus or minus The square root of 25 plus 96 is 121. Divide this by 2. So we can now further simplify this into 5 plus or minus the square root of 121 is 11, and divide this by 2. So from this, you are now having two different values because of plus and minus 2. So let's break this down into two different x values. We have x equals, the first one is 5 plus 11 over 2. The second x value is x equals 5 minus 11 over 2. 5 plus 11 is 16, so it is 16 over 2, and this gives you 8 as one of the zeros, while 5 minus 11 is negative 6, and that is over 2. The answer is negative 3. So there are two x values in this example. X equals positive 8 and x equals negative 3. So take note that what is inside the square root sign, which is also called your discriminant, is positive 121. So it tells you that the function has two distinct real solutions, and the solutions are x equals 8 or x equals negative 3. So you can put your solution inside a bracket. Let us go over example number 2, where the value of a is not anymore equal to 1. So let's have the following values taken out. So a is equal to 2, b, the coefficient of x is negative 3, and c is negative 5. So let's write down the formula for the quadratic formula. It starts with x equals the negative of b plus or minus square root of b squared minus 4 times a times c all over 2 times a. Okay, let us then supply the values into our given formula. So we have b is negative 3, so it's negative of negative 3 plus minus the square root of b squared, that's negative 3 quantity squared, minus 4 times a is 2, and times c is negative 5 all over 2 times 2. The value of a is 2. So let's now simplify this. We have negative of negative 3 is positive 3 plus or minus the square root of negative 3, or negative 3 times negative 3 is positive 9. Negative 4 times 2 is 8. It's negative 8, and then negative 8 times negative 5 is positive 40 all over 4. Now we can simplify this further into 3 plus or minus the square root of 49 over 4. And the square root of 49 is 7, so this is equal to 3 plus or minus 7 over 4. So from this, you can now divide them into two different equations to solve for your zeros. So we have x equals, the first zero is using the plus 1, so 3 plus 7 over 4, while the second zero is x equals 3 minus 7 over 4. So 3 plus 7 is 10, so we have 10 over 4, and we can reduce this by 2, so the answer is 5 over 2. This is one of the values of x. The second is using the negative 7, so 3 minus 7 is negative 4 over negative 4, and this is over positive 4, and this is equal to, this time, equal to negative 1, which means that our two x values are 5 over 2 and negative 1. So if you also go back to what we talked earlier, the value inside Your square root sign, which is called your discriminant, tells you how many zeros do we have. So if it is greater than 0 or positive value, it means that you have 2 zeros coming out. And indeed, the discriminant is telling us that we have 2 different zeros coming out in this example. Let us go over example number 3 this time, where we're given the function f of x equals x squared plus 4x plus 5. So the value of a is 1, b equals 4, and c equals 5. So let's check and write down the quadratic formula. Now, let us supply the values of a, b, and c into the formula. So we have the negative of b, and b is 4, so it's negative of 4, plus or minus the square root of b squared is 4 squared, minus 4 times a is 1, and times c is 5. This is all over 2 times 1. Now we have negative 4 plus or minus the square root of 16. Negative 4 times 1 is negative 4, times negative 5 is negative 20, so minus 20 all over 2, because it's 2 times 1. So we have negative 4 plus or minus the square root of 16 minus 20 is negative 4 over 2. Now we have a problem, because in your freshman algebra class, we don't deal with this type of values. We'll always say that, oh, there are no real zeros for this. But in Algebra 2, we're going to introduce a concept on imaginary numbers, which will actually help you simplify this type of problem. Let us forget about this part first, and let's go back to this later on after we explain what are imaginary numbers.